What thing? I know that English homework was not meant to.
I can.
It was like 20 pages.
No, that's why we have other chairs. Did you not see these ones? Right here.
Come here, Travis.
Put it right in front of the board.
I would do it too.
Shut up.
You're on that side. I have to be punctual. Do you have a folder, Lino? Or a binder? Why don't you do that? That's fine. You can always just pull a desk up too. As long as you're back.
It was Rachel.
I'm already here.
All right. The first example is an example that you'll see on an SAT. And the reason I wanted to start with this one is because it's not difficult as a mathematical problem, but here it gets a little bit confusing because they use the term thousands several times. Okay, so we're going to be looking at a problem where they're given certain values, but you have to think about the fact that if I said I have $5,000, okay, it would be like 5000. Or I could say the number 5 and then write the word thousand after it. Now, it's a little bit tricky in this problem because you want to think that it's a simple substitution problem where you can substitute and directly evaluate it. But you have to consider the term thousands. So I'm going to go slowly through this. And again, today's topic is polynomial evaluation. We talked yesterday about how we're starting polynomial functions. Okay, what does the word poly mean to you? Many, very good. So when we talk about polynomials, we are talking about anything above, well, not above, but anything that has x in the terms. So we're looking at something like this. We're looking at a function that might say f of x equals 2x plus 1. Well, that's a polynomial, but it's just considered to be a line or linear. Then we talked about something where we had x squared, like x squared plus 2x minus 4. What did we call that? Quadratic. It still is a polynomial, though. Okay, it has many terms to it. Now, after this, what happens if we have x cubed? What if we have something like k of x equals x cubed plus 2x squared minus 4? Something like that. Now, we call that a cubic, but in general, we're just going to call these functions polynomials. Okay, so polynomials where we have x to some degree. So we're going to have x in there, and it's going to be raised to some power. Later on in the year, we're going to talk about different types of functions that are not polynomials. We're going to look at rational functions, which are just a fraction, so a numerator over a denominator. We're going to look at exponential growth and decay. We're going to look at trigonometric functions, so this using sine, cosine, and tan, and graphing those. For now, though, what we're going to start today is looking at polynomial functions. And that's a good example of a polynomial function. It has many terms to it. Now, the topic is called polynomial evaluation. What does the word evaluate mean? And don't think about it in terms of English, but in terms of math. What does evaluate mean? It's a term that most people don't know right away. Evaluate.
To break down.
Not break down.
Well, figure out.
Okay, more than that, John. Figure out is on the right track because that's not exact. Not solve, though. It's not solve. And that's the common misnomer is to say solve. When you solve something, you're looking for a value of a variable, correct? So you're solving for x or you're solving for y. Okay? Evaluation and solving are two completely different words, so please don't confuse them. Victoria, you want to help us? You had a hand. No thought there? John? Not figure out the variable. All right, it's good that we talk about this then, because we have to know what this word means. Because if a problem says evaluate the function at x equals 4, now what does it tell you to do? What does that mean? Evaluate the function at x equals 4. Okay, answer, sure, that's fine, or find the value when x equals 4, as Vanessa just said, substitute. So if you're thinking about the word evaluate, here's what I want you to write down. When you think about the word evaluate, think about plugging in the x value. That's all you're doing. That's what evaluate always means. It means you're plugging in some values and you're getting an overall expression, but you're not solving for a variable here. Again, you're not really solving for a variable, as in the terms where if we set this equal to 0 and we solve for x, we're finding the roots. That's solving for a variable. Okay, that would be solving for x if you can figure out what x is. But evaluate means when you plug a number in for x and you get a value of y out. Okay, so for evaluate, you plug in the independent variable. Now, the independent variable could be x, it could be t, it could be w, it doesn't matter. But remember, the independent variable is this one over here. It's the one that's in the parentheses of the function. The dependent variable is this part right here, which we call y. Again, so evaluate, remember, you're plugging in for x to get a y value. That's what you're doing every time. You're plugging in for x to get a y value. Now, this comes up on every single SAT. Simple problems that just say, evaluate the expression at this location, or evaluate the expression when this equals this. And most of you are good at that because you have that. But when we talk about a problem like this, where we're going to be evaluating, we're not going to see the word evaluate anywhere. But we still have to realize that that's what we're going to be doing. Okay, it's not going to say necessarily to evaluate a function. All right. Going through this problem, who can give me some key points? I've already written it down. What do we know about this? What are some things I want to underline or things I want to ignore? Anthony? Okay, good. Right away, you're given a function somewhere, so this is probably some piece of information that we're going to use. Anthony, what is that a function of? So just describe the function there, based on the words you see in the problem. Okay, and what does P stand for?
Y.
Okay, very good. P of x is y, but in this problem, using your words from the word problem, what does P stand for? Be careful. Joey, help me out. P is the profit here. X is the number of cars made. Okay, P is the profit. It says X is the number of cars sold in thousands per year, and P is the number of dollars made or profit in thousands per year. In thousands per year. So again, P is the profit made, X is the number of cars sold in that year, in thousands. So, here we have a car dealership that sold 3,500 cars in 1 year. And the problem asks, what is the profit? Okay, what is the profit? Can I get a suggestion on what to do here? Luis? Okay, plug the number in, and for what? In for x. Why x, Luis? That's correct. Again, 3,500 is the number of cars sold. And a minute ago, we said that x is the number of cars sold. In thousands, though. In thousands. So this is where it gets tricky. You can't just plug in 3,500. And a common mistake on the test would be to plug in 3,500. It would be 3.5. How come?
Because in thousands is 3,000, then 500 is half.
Absolutely right. Take a look here. So if we have
a car.
It's not, though. It's just a function you're plugging in. You're still selling 3,500 cars. So 3,500 is really 3.5 times 1,000. That's what it really is equal to. So in your mind, you need to be thinking of 3,500 as 3.5 by 1,000. Multiply them. Just move the decimal 3 spots. So this is 3.5 thousands. Again, this is 3.5 thousands. This is 3,500. It's the same number, but we want to know, it says the number of cars sold in thousands. Okay, so x in this case is going to be 3.5. That's the key. And that's the hardest part of this entire problem. Realizing that you're using 3.5 and not 3,500. If it's as in thousands. If it said this, let's go over, that's a very good question, Miguel. What if instead of saying in thousands, it said in millions, and the number was, and it said the number of cars sold in millions. How many millions would that number be right there, Juliet?
No, it's 27.
27.
Yes, it is. I know. Let her. You know what it is
Well, I'll
now?
take the answer then. She's not gonna say it.
27, 2454 by a million. Oops. By a million. Again, 27 million. So we're looking at 27.454 million. So if this problem said the number of cars sold in millions, you need to move the decimal over 6 spots. Here's a simple way to think about it. I see both your hands. Look at the number of zeros. Look at the number of zeros, please, in the number. That's 6, right? Take the decimal, move it over 6 spots. Move it to there. You're going to get 27.454. There's 3 zeros. Take the decimal, move it over 3 spots. There's 3.5. It's just like scientific notation. So remember how you learned scientific notation? And it's not, scientific notation is not used that much in the math and science field unless you're looking at numbers that are very large or very small. So if you're working in nanotechnology and you're working with microscopes and you're working with electron microscopes, which are at a lower level, they're looking at things that are like 0.00001 meters or 0.001 feet. That's where you use scientific notation a lot. Or if you're looking at say you're an astrological physicist. I think that's the right word. Or no.
So I remember what juniors.
What is?
When juniors keep the vocabulary real.
That's not that hard.
John, you're interested in this though. What is the term for physicists that are studying the universe?
Cosmologist.
Cosmologist might be it? Okay. So say you're working on studying the universe. And if you're looking at things like distances, you're looking at orders of like millions and billions of miles. So you wouldn't say like, okay, it's, if you're using something like 284,361,271 miles, you're not going to say, that.
It's just a million. It's not that
Okay?
hard.
Okay, 284,361,271.
You learned something today, Derek.
Okay, whatever you see
Big
here,
numbers. That's
whatever you see here, say million.
big word.
Whatever you see here, you say
I
thousand.
say 30. So.
Derek, I'm talking to you. You say million for this, thousand for this, and just repeat that number. Again, you're not going to use this term. You're going to use scientific notation. So this is an example of this. So in this problem, you're really using scientific notation, whether you realize it or not. Okay, you're using scientific notation.
I have a question. I was going to ask you about this, but technically it's not fully scientific. Scientific.
No, you're absolutely right, John. Why?
Because it's between 1 and 10.
Absolutely. True scientific notation only has 1 digit to the left of the decimal. This is truly in scientific notation. This is not. But this number is correct still. This is the number you have to use. You do not use 2.7 here. Again, you do not use 2.7 because this problem asked in millions. Millions are up to here. So what's left over after you take out the millions, this is what's left over. If this number had been, instead of 3,500, if this number had been 43,500, your number would be 43.5. Okay, because it's in thousands. In thousands means move it 3 spots over. It would still be 43.5. But here we're using 3.5.
What would happen if you plug in 300
You would get an answer that would be much, much larger than it should be because you're going to be raising the number to the 5th power. Okay, that's the issue you're going to run into. No, don't. You get a different answer. You can't raise it to the power and then divide by 1,000. It doesn't work. Guys, who heard Ashley's problem? Because you're all talking, and I guarantee you this is a problem everybody else has. Can you explain it to us? Eric, explain what we just said.
I was right here. She said, what happens if you plug in that 3,500? Would you get like the same answer? And you know you would because if you do, that X will be up by 5, so that's like a huge number right there.
Up by 5. Use your terms right. Come on. What is it?
Raise to the 5th power.
Raise to the 5th power.
What is the P power?
Thank you, Derek. You're absolutely right. Again, 3,500 is a number that we're going to raise. Now, if we raise it to the 5th power, it's going to be an immensely large number, as opposed to raising 3.5 to the 5th power. So if you raise 3,500 to the 5th power, and then you try and like divide by 1,000 to take account for it, it won't work. Again, it's not going to work that way. So you have to take account for it before you evaluate. Now, at this point in time, we know the value of x is 3.5. So go ahead, plug it in here, plug it in here. Tell me what you get for the product, please.
if you're saying raise, you're being more specific. You're saying that you're raising the value, taking the value up.
Number
You say
one.
up, it's like a graph.
It's like when you said
Up could mean anything. Up could be like up a graph or something.
No, seriously.
like raise is
Raise is more specific. Up is more broad. So we don't want that.
That's my skin color.
Guys, show me what you get. Let's go. Show me what you get.
I'm not good at math.
That's the profit in sales.
How did you listen to me? I shouldn't be in this class.
That
What is 3.5 raised to the fifth power?
That's the problem with
Oh.
thousands.
So you have to move it
You multiply it or add?
How much money is that really gonna make?
That's the profit in
Yeah,
thousands.
so you have to move it.
Whoa.
Somebody did something wrong.
Somebody's
calculator?
No. You gotta push it to the thousand, right?
Let me just.
Let me get my calculator. You guys are actually solving it here.
I don't know what you're supposed to do after you get it. Push it back to the thousand.
Holy snap!
3,500
to the fifth power.
That's millions of millions because parts are
Oh, got snacks.
Wait, what?
Did I plug it in?
What's it that's
What do you call this overall?
Oh, what do you mean?
Why don't you just plug it in like
I'm saying like the majority of them are like
Said 50.4.
let me see what you want.
3.5.
It's actually 200.
So let's go my answer.
No.
Yeah.
I got the last part. To make it.
What's the last part?
part is plus.
So what would you do once you get the answer? So like you have to change it.
So you got it?
No, that's it. That's the minus. That's when you minus 14.
That's the answer in thousands. Keep that in
Oh,
mind.
so you got
Thousands.
That's what I'm saying. So
What's the actual profit gonna be?
So which one would you go with?
Says that's the answer. Yeah. Profit in thousands.
Man, you guys are acting like little kids.
They must see.
Take that over 5.
Whoa.
Yeah, listen. Might as well be. 5, 10, 15, 20, 25.
This answer, that's
I
What was your answer?
See, I was right. It was like 10 points. Something. 10, 50.475.
Alright, let's go through this. Can you what?
Too bad at 9.
Yeah, you can explain it.
But you just missed the 5 at the end.
So it's 4.75, correct?
Alright, now, let's all listen carefully. This is a tough point to go through now.
Pay attention.
This problem is tough because at the end we have to also make an adjustment. Several of you noticed it. Okay, several noticed it right away. There's an easy way to explain it that I'm going to try to help you with. for this problem, when we plug in the 3.5, Derek, what'd you get when we plug in 3.5 here?
For the answer,
Yep, just before you did anything else.
I got 1047.
Point.
0.1875.
Okay, so let's say 1/8. So that's the answer you're going to get when you plug it in. Now, in a minute we're going to show how we can do this with a table also, but for now let's discuss our answer. This is the answer of the profit. Now, look at the value of P, or look at the definition of P from earlier. It says, P is the number of dollars made in thousands per year. Take a look again. Over here. P is the number of dollars made in thousands per year. So, if I made, and this is where it's going to get a little bit weird to look at, if I made $5,000, I can write it like this, 5,000. Or I can write 5,000 as a number, 5,000. Those are synonymous, right? Same thing? So, this is the amount of profit the person made or the company made in thousands. In thousands. So this is like, see this is 5,000, this is 1,047 thousands. Again, this is 5,000, this number here, and then we added 3 zeros to it. This is,
You cleared
this
it.
is,
Oh, yay!
relax guys, just change the page. This is 1,047 thousands. Thousands. So when we had 5,000, we added 3 zeros to it. We added 3 zeros to it. So many of you noticed we have to do the same thing here. So this is not our profit. Our profit is that number times 1,000. Times 1,000. Again, our profit was in thousands. So 1,047 thousands is really with 3 additional zeros. So we're looking at 1,047,000. Or we can just say move the decimal 3 spots because we're going to have some left over there. So if we move the decimal 3 spots over, like that, we're going to see we have 1,04718. What was the next decimal?
7.5.
Thank you. 7.5. And take a look. Look at your actual answer. Instead of being 1,000, it's around 1,000,000, right? And 1,000,000 is 1,000 times bigger than 1,000. Again, we are multiplying our answer by 1,000 to get this. We are timesing our answer by 1,000. Okay? So, and let's think logically, people. If you by accident, let's say hypothetically, you're taking the SAT and you decided at this point to divide by 1,000. What would the profit be? What would it be? If you divided by 1,000. If you, instead of multiplying by 1,000 here, you divided by 1,000 by accident.
It'll go down. It'll go down.
Very good. It'll be $1. Move the decimal 3 spots. 1, 2, 3. That means they have a $1 profit.
Something makes
Okay?
some money.
Usually, you don't stay afloat if you have a $1 profit.
I
Unless
can
you're
make it
selling
work.
lemonade in the corner or something. I don't know.
Oh.
Okay? But you do not have a company that has a $1 profit and stays afloat. So think logically. Now, the next thing I want to show you guys. See how we did all this work by hand? You can always do it by hand. But you can always also use your table function. And many of you already know this. In case you don't, let's quickly run through.
How do you guys do people?
Go to y equals, please. So clear everything on your screen. Go to y equals in the upper left corner.
Because it has been changed to Windows 7 basically.
I couldn't hear you, Anthony. Sorry. Maybe. Maybe not. I don't know. This, guys, again, this topic is about function evaluation, plugging in a number. I'm bringing in the scientific stuff just so you can see how it's affecting your SAT. The topic we're learning right now, though, is evaluating a function. So the whole 1,000 thing was just me making the problem harder for you so you can see what you'd expect on an SAT. Okay? But that's not the topic we're assessing right now. We're assessing the fact that we're going to be evaluating. In a minute, you're going to see that we're not even going to use this table function. We're going to do it in an even different way, which is called synthetic. And it's a whole new topic that nobody's seen before. It's very simple, though. So if we go to y equals, go ahead and type in your function, please.
The whole function?
The whole thing. So 2x to the 5th What do you do to the fifth power?
Carry 5.
Very good. Caret 5. Remember, there's no fifth power key on here. Caret 5
3x.
plus 3x.
Is there another name for it, or is it just carrot?
Raise it to that power, but do you want to say that every time?
Carrot, John. I don't want it to be carrot.
I thought it was raised to the two.
Best friend.
Shut
up.
Alright, now, thank you. At this point in time, here's what I want you to notice. All we've done is put in a function here. What is our x value going to be that we're going to plug in?
3.5.
Very good, 3.5. Now, many of you, if you just hit table right now, and table again is the second then graph. If you just hit table, a lot of people already have numbers in the x column. Okay? You don't want the table set up like that, pretty much ever. It's a waste of your time. So what I want you to do is the following. If your table, let me just change mine to make it look the way yours would look. If your table currently looks like this, where it picks the numbers for you, and you can simply scroll up and scroll down, you're not going to see 3.5 in there anywhere. But I want to get 3.5. So either I could change my settings and change my interval, and I can make my delta 0.5 so that it goes by 0.5s instead of 1s. It'll be like 0, 0.5, 1, 1.5, 2, 2.5. But I don't want to do all that work. So just change independent to ask. And what this does is, it enables you to ask a value of the independent variable. The independent variable is what variable again? X. So it enables you to plug in your own x value. Now go to your table. It's going to look empty. Type in 3.5 under x. And just hit enter. Whoops, not 2.
Oh, I see, it's 10.47. No, it's in.
You're going to see the same. Okay, do that again, everybody. Follow me. Ready? Second, table setting. Table setting is on window. Go down to ask and then auto. It's got to be in this order. You're asking the independent, and it's automatically giving you the dependent variable. The dependent is the y. It's automatically giving you that. So ask, then auto. Then press second, go to your table, under your x. If you're not in your x column, if you're over here for some reason, go over to x, please. Again, if you're over on the y column, go back over to x and plug in the number. And you have to type in 3.5, enter. Go ahead and type it. If you don't have any numbers, type in 3.5 and hit enter. You are giving the calculator the x value. It's not going to have it there for you. Again, this process is very useful when you're trying to evaluate a function over and over again. So let's say I want to know what the profit was after 5,000 cars were sold. Just type 5 in. Hit enter. If I want the profit after, I don't know, 20,000 cars were sold, type in 20, hit enter. And take a look here. What does that E mean again?
That means it goes on for 6 more spaces.
6 more spots. So just to quickly note here, in case we're confused, this E right here. Well, I'll show you over here actually, it's bigger. This means exponential, very good, or times 10 to the. So this is really 6.4 times 10 to the 6, which is 6, 4, which is that number right there. Again, this number right here is that number written down there, 6.4 million. Okay? So again, this E6 here, whenever you see this on a calculator, even on the home screen, E means times 10 to the. E means times 10 to the whatever you see here. See how there's a 6 on the end? That became the exponent. 6.4 became the number in the front. And then I evaluated it. Okay? Again, this 6 means move the decimal 6 spots. 1, 2, 3, 4, 5, 6. Again, that was 1, 2, 3, 4, 5, 6. So when you have a table and it says E there, it just means that the number is too big, the table can't show it, so it's going to use scientific notation. Okay? Again, the table function is handy when you're evaluating at several different points, like we just did here, 3.5, 5, and 20. If you're only finding the value at 3.5, it's really not worth it that much to use the table. Okay, again, if you're only finding the value at one location, it's not always as worth it to use the table. But sometimes the table does take into account some small errors that people have. So make sure that your equation is typed in correctly. Who noticed? I screwed it up at first. What did I forget when I typed in the equation? The squared. And if I forget the squared here, it's a very different number. So make sure you're very careful and you're tedious. Okay? Make sure that you sit there and you go through each one. Make sure every single thing is correct before you actually go to your table. All right. Now, that's a simple side note to use your calculator. It is useful to do so. Now, if we go back to our example, our answer again is about 1 million. Okay, a little over $1 million. And that's the profit for the company for 1 year. Now, that kind of a problem, it just took us about 20 to 25 minutes to go through. And I know it wouldn't take you 20 to 25 minutes on your own, but this kind of a problem is supposed to be 1 minute in the SAT. Okay? So keep that in mind when you're doing these things. You get about a minute per problem. This can be a very simple problem on the SAT that they'll use here. I wouldn't say it would be an easy level problem, simply because of the thing with the thousands. If you didn't have the thousands there and you're just plugging in 3,500 and getting an answer, then it would be a very simple problem. But I would say this would be like a medium to more difficult level problem. Okay? Closer to the medium, but not as easy as some of the other medium level problems. All right, let's go on to our next problem. Example 2. For this, we're going to start something called synthetic substitution. So what we just did a minute ago was called direct substitution. We substituted the number into the equation directly. We simply put the 3.5 into the equation. Take a minute. Please copy down the heading, synthetic substitution. I'll go over this little hint at the top also, and then write down the problem, please. So synthetic substitution. This method is traditionally used when the independent variable, x, is an integer, singular, not plural, is an integer, and when exponents are large. Okay? And you're going to see why in a minute. It's very easy to use this method. In this problem, we have x to the 4th here, and we have a 3. We can plug it into our calculator and figure it out, and that's fine. We can always do that. But we're going to use synthetic substitution in the next few concepts, and you're going to see where it comes into play. For today, we're going to say that we're really just going to use it when the x value is an integer, and you have some sort of a higher exponent. Okay, you might not want to do 3 to the 4th. Granted, 3 to the 4th is 81, one of the ones that you might want to memorize. But again, that's traditionally when we're going to use it when x is an integer, and we have a higher exponent. So, data for a statistics company follows the function g of x equals 3x squared minus 2x to the 4th plus 7x. Determine the value of the function when x equals 3. Determine the value of the function when x equals 3. So again, you can just plug in a 3 and get your answer. When you're done copying, use your table function. Do not plug in on the calculator on its own. Try the table function here. So go to y equals, change your function. Again, change your function to this. Type in a 3 on your independent variable x and tell me what the y gets and write it down. Give yourself a little note. And then we're going to show how to do this a whole different way. No, because we see how this gets the 4th. In 10 minutes. We gotta do 3 to the 4th, and then we'll do 2. Oh, do 2 times 3, right? Yeah. Again, guys, if you're doing this by hand, PEMDAS, you have to raise 3 to the 4th and then multiply by 2. Don't do 2 times 3 and get 6, and then do 6 to the 4th. Again, this is really like that. Do 3 to the 4th first, and then multiply by 2 there. Be careful. What's that? It's probably going to be a negative number because it's going to be such a large negative quantity. I got... I trust you. I it's a problem here. Change it. I doubt it goes. Ashley, what'd you say your number was? What'd you get?
Negative 132. I got 114.
Yeah. 114. Anybody get negative 114? You got negative 114? Yeah.
Chop it around.
Are you using a table function?
You know what? I know that.
Okay. Again, if you plug in here, you're going to get g of 3, and if you plug in the whole thing, you probably get negative 114. Now, if you didn't get that, go back and look. Look at your y equals, make sure your equation's right, or go in and see what you made a mistake in. Make sure that you plugged in a 3 and not a 3.5. In the last problem, we plugged in 3.5. So you have to change that value. Now, this is one way of doing it, okay? Now, there's a whole other way of doing it we're going to start right now. It's called synthetic substitution. synthetic substitution. Here's how synthetic substitution works. And I'm going to give you guys steps. There are a few steps here. If you're a person that likes to write down steps, this might help you. It's a very logical thought process we're going to go through. If something doesn't make sense, please ask. Okay, if I'm in the middle of talking, ask Mr. Carter. He'll help you with it as we go through it. It's not easy the first time you do it. First time you go through this, a lot of people get confused right away. But as you do it more and more, it gets very simple. And it becomes second nature. It's almost like adding. It's very easy. So here, start, first step, by reordering your polynomial function from the highest power to the lowest power. So reorder the function from highest to lowest exponent. Reorder, it is extremely important that you do this. If you don't reorder it, the process will not work. It only works if it's highest exponent to lowest exponent. So here, what do we have to really change? Good, those two circle. Now remember, when you reorder this, the negative goes with the 2. It becomes g of x equal negative 2x to the 4th plus 3x squared plus 7x. Again, remember, the negative goes with the x to the 4th and the 2 there. The negative goes with it. Now that we're in order, the second thing is to note. Take a note of any missing terms. If you were to go through all the exponents, what terms are missing here? Good, x to the 3rd. And what else is actually missing?
There's no, like, minus,
What is that called? The number at the end, what do we call it by itself? Constant. There's no x to the 3rd term, and there's no constant. Note that in your mind or on the paper. Do not forget that. It comes into play. There's no x to the 3rd, and there's no constant.
Isn't this similar to something we did like a few years ago, where we had something like this, but instead of where this was to be like the exponent 3, you put like a 0, x to the 3rd, and then at the end you put like a 0.
Sure, it's set up that way, but it's not the same. We've never done this before. It's the same order as in like what are we looking at, but we're not going to put zeros in or anything anywhere. Okay? We're going to use zeros for the missing ones that we have later on in a chart. If that's what you're talking about. Is that what you mean? We're going to put a 0 in here, and we're going to put a 0 in at the end for the missing parts in the chart that we're going to make. But it's nothing that we've done before. We might have used the 0 idea before. Now, continuing this process. So again, the first step was to reorder. The second step was to note any missing terms. And you don't have to note it on the paper. You can do a mental note if you'd like to. That's fine. Okay, do a mental note. Third step is to create a table. Let me show you how the table looks. When you're creating a table here, you want your table to look like the following. You want your table to look like the following.
That would be the third one, right?
Or on the third step, make a table, yep. Okay, we're making a table here. Now, what you need to do is put all of your coefficients on the top line, accounting for the zeros. So if you're missing something, put a 0 there. So start with -2 here, then a 0, then a 3, then a 7, and then a 0. Okay, so if you're thinking about like the matrix, Juliet, is that what you were thinking of? Or we accounted for the zeros in the matrix? Remember if we're missing a term in the matrix, you put a 0 there? So if you had A, B, and C, but for one equation we're missing C, we put a 0 as a placeholder in the matrix. Same idea there. Now, there are 5 numbers up top. How come there are 5 numbers and not 4?
Because you have to count the exponent plus the constant.
Absolutely right. What is the highest exponent here? 4. Well, we also have the constant, so there'll be 5 terms here. Again, 4th, 3rd, 2nd, 1st order, and then the constant. Now, on the outside, what you want to put is the value that you're going to be evaluating for x, which was what number again? 3. So put a 3 over here, please. Now, the next process is where it gets a little bit tricky. And it's not tricky, it's just a matter of memorization of what to do. So I'm going to try and show you guys one step at a time with several colors here. First thing you always do, okay, first thing you're going to do here is bring down the -2. And here's what I mean. Just recopy the -2 here. Okay, bring down the negative 2. Now, what I want you to do next, and if you're writing down steps, that would be step 1 under this table. So if you're writing down like the sub steps for the table, you want to bring down the leading coefficient, which is negative 2. Okay, again, you want to bring down the leading coefficient, which is our value, negative 2. Next, multiply these two here. Multiply these in your head and add this number to it, which is 0, so it doesn't matter. But multiply these numbers, okay, and then add the next column to it. 3 times negative 2, negative 6 plus 0, and then write that number here. Again, this, come in. Multiply these two and add this number. Okay, just because it's a 0 doesn't mean it doesn't count. Trayvon? No. You'll be, no, in like 2 or 3 minutes. Okay. So, again, 3 times 2 is negative 6. Negative 6 plus 0 is negative 6. Okay? Now, what's the next step probably, Juliet? 3 times what now? Instead of the negative 2, what should we do? And then add to that what? The 3 up there. Very good. So pick up on the pattern now. So the first time, we multiplied these, we added this number, and we got this number right here. Now we want to multiply instead of that, we want to multiply these two instead. We're done with this now. Multiply these and add the 3 then. 3 times negative 6 is negative 18. Negative 18 plus 3, negative 15. Be careful. Be careful. And you continue the process over and over and over until you get to the end. Now, let's do mental math, people. 3 by negative 15. Negative 45 plus 7. Negative, very good. Negative 38 times 3. What is it? Negative 114. What's negative 114 plus 0? What was our answer last time, guys? There's your answer. The exact same thing. Now, there's a reason, trust me, there's a reason you're doing it this way. If we want to use this technique, which we're going to in about 2 or 3 other concepts, we have to use this technique, we have to use this method to solve. Okay, again, it is extremely important that we understand this. Right now it seems like, oh, you know what, that was a lot of work. I can just plug it in the calculator. And you can. But we're going to see how this affects us in a little while. Now, before we conclude this problem, we want to make some sort of a statement about what that negative 114 really represents. What does the negative 114 represent here?
The statistic. No, they.
Y equals x is 3.
Say again?
Y equals x is 3.
That's exactly. Say that nice and loud, Derek.
Well, y equals if x is 3.
So the negative 114 represents what y equals when x is 3. So what I really have here is a coordinate. The coordinate is 3, comma, negative 114. That's what's going on here, really. I plugged in a 3, and what did I get out of the function? Negative 114. Just like if you plug in your table, your x value plugged in 3, under the y1 column, you got negative 114. Okay? So we call this number at the end of our synthetic chart the y value. The number at the end of the synthetic chart or the synthetic table, either way you can call it, is the y value. Okay? If some of you, did anyone else write down other steps here? It's tough to use words to describe what we're doing here. But you really want to multiply the numbers next to each other, add the top of the next column. Multiply the next number, add the next column. Multiply the next number, add the next column. And go through this process over and over. Okay, if you want to write in words, you can write your own name. So again, this is the y value. Another word for the y value that mathematicians use is the remainder. So just know that word. Okay, we're not going to use it as much, but it is good to know the word remainder. Whoops. ER. Is that used where? It is. It's similar to division. And when we get to synthetic division, we're going to use the term remainder just like you would with long division. Trayvon, go. I just want you to get to the end of this problem. Then we're going to miss it.
All right.
Okay, next problem what I want to work on. Let me just make sure. Let's see. Oh, there's one more thing I do want to point out actually before you go. Here's a question for you to think about. What if the remainder was 0? What does that mean about this? What significance does it have if the remainder was 0? The x-intercept. Awesome job, Victoria. I didn't think anyone was going to get that right away. Great work. Again, if the remainder is 0, it makes this point what? It makes the point 3, 0. When you have a y value of 0, you're really looking at the roots, or the x-intercepts, or the zeros of the function. So the point 3, 0 would be over here at 3, 0. That's where that point would be located. So write this down, please. If the remainder is 0, the x value you plugged in is a root. If the remainder is 0, the x value that you plugged in is a root, or an x-intercept, or a 0 of the function. You can call it any of those. Call it a root, call it an x-intercept, call it a 0 of the function. Any of those above. The video will be up to that, so just watch the rest of the last part. And the notes are also online. All right, let's try the third one. Solve this both ways, please. Use direct right away, and then use synthetic. Use direct, and then use synthetic. It's pretty pointless to use synthetic in a problem like this. I'm just doing it for you to practice, that's all. Because it's only x squared here. Again, I want you to practice, absolutely. Again, you're just practicing, guys. But if you did this on a test, and you were trying to find out the answer, you would not really use synthetic here. Again, it's not worth your time. I want you just to practice. That's all we're doing this for. If the height of a projectile above ground in feet is shown by the function h of t equals 5t, h of t equals 5t minus 2t squared plus 3, then find the height after 2 seconds have passed. Find the height after 2 seconds have passed. What does t represent always, guys? Time. If you see capital T, what does that represent? Temperature. Very good. Same thing. Plug in the 2, get the number using direct, and then try using synthetic. Okay, so again, I want you to do it 2 different ways. First way, I want you to use direct. And the second way, I want you to use synthetic. Okay, use direct first. Just do h of 2, use your table, or just type it in, or do it in your head. You could probably do this one in your head. Please, guys, the mistake here is forgetting the negative with the 2t squared. Okay, make sure you carry the negative wherever you move it if you're going to reorder. Are there any zeros this time? Are there any missing terms? You got t squared, you got t, and then you got a constant. There's no missing terms. So there's not going to be zeros this problem. Okay? Guys, again, there's only zeros along the top if you're missing a term. If you're missing a term. So for direct, you don't need to reorder it. Remember, you don't have to reorder it for direct. It does not matter. Okay? Again, you should have gotten 5 for direct right away. Again, be careful. You got to do 2 squared and then multiply that by 2. Remember, this 2 squared here is really 4. So it's 4 by 2, which is the 8. Don't make the common mistake there, please. Synthetic. What should the order be along the top, people? Negative 2, 5, and 3. Again, for synthetic, you have to switch the first and second term here. The negative 2t squared has to come first, then the plus 5t, and then the plus 3. Again, make sure you carry the negative sign. This whole term has to swap with that whole term. Okay, running through here. Let me move this up so we can all see better. Running through this process, what do I do first? Derek. Drag down the leading coefficient. Next, what do I do? Next, what do I do? Claudia. Good. -4 plus 5 is just 1. Again, this is 2 times -2 is -4. -4 plus 5 is +1. What's 2 times 1? 2 plus 3 is 5. Same answer. Okay? Exact same answer either way. Again, when you're given something like a quadratic, it's not as important to use synthetic, but I want you to practice it. I want you to practice it. These kinds of problems are going to come up again and again. We're going to use this table over and over again. In the last 2 minutes, try this one, please. I'm going to give you your homework in a sec. I have a worksheet for you. Try finding f of 4 if f of x is equal to. Now, in this problem, direct is going to be really messy, unless you use a calculator, obviously. Okay? But I want you to try synthetic here. If f of x equals 2x to the third plus x to the fifth minus 7. Try that. Hey, don't forget your 0 placeholders. Don't forget your 0 placeholders. Did anybody print the notes that I put up for this concept yet? Okay, I'm going to alter them because I thought of something different, so I want to change it. So don't print them until tonight, if you do. I'll explain your homework in a second. Just take a worksheet for now. Please don't start it yet. Work on the problem you're doing. I want you to try synthetic on this one. If you want to check your answer, just use the table to check. But do synthetic for this problem that's on the board.
What's the number? What's the number? What's the coefficient? 4.
If you're confused at all about what you're doing right now, please raise your hand. We're going to use this technique over and over again. You want to do this now? This is your homework. Just hang on to it for a minute. If you're done with the problem, you can start it, but I want to explain what you... Well, it's in the directions. Just read the directions. If you finish this problem that's on the board, feel free to go to your homework and look at the first one. You got about a minute till the bell's going to ring. There are 6 of them for you to practice, yeah.
Where's the next to the 4th?
Check your numbers with mine on the board already. Don't forget those zeros there. And I put it in the correct order there. Uh-oh. What did I forget? Which one? Thank you.
Is there an next to the 3rd?
So 2 0.
Don't forget a 0 here. Don't forget a 0, like I did. Okay. Why are there 2 zeros? We're missing x squared and we're missing the x. X squared and x are missing. The -7 is the last number. Whatever the constant is, the number by itself without the variable, is always the last thing. If there's nothing there, then there's a 0 there.